So here we're exploring an adaptation of the average rate of change, the difference quotient. Now, being able to simplify a difference quotient is an important skill that's going to follow us through our calculus careers. Now, suppose that the ordered pairs x plus f of x and x plus h f of x plus h are 2 points on the graph of a nonlinear function. So we have the 2 points on our nonlinear function, or the graph of our nonlinear function. Now, using what we know from the average rate of change, we have the following. So by the average rate of change, if our function f is defined on the interval of x values from x to x plus h, then the difference quotient can be thought of as the slope of the secant line passing through these 2 points on our curve. So looking at the graph, and the secant line is a line passing through these 2 points. So connecting these 2 points with a straight line, we can see the graph of our secant line. And just like with the average rate of change, we can use the slope of the secant line to find the difference quotient. So we can say that the difference quotient, again, is an adaptation of the slope. It's the change in the y values by the change in the x values. Again, thinking back to our definition of the slope, we know that this can be thought of as y sub 2 minus y sub 1, all divided by x sub 2 minus x sub 1. Now, these are the 2 points that we're thinking about. So we can label this first point as x sub 1, y sub 1, and our second point as x sub 2, y sub 2. So plugging these points into the slope formula, we have f of x plus h minus f of x, the change in the y values, all divided by the change in x, which will be x plus h minus x. And notice here we have 2 like terms, positive x, negative x. These terms will cancel each other out, leaving us with our simplified difference quotient, f of x plus h minus f of x, all divided by h. So this is the simplified difference quotient, an adaptation of our average rate of change and slope formula that's going to be important for us to keep in mind as we proceed through calculus.